let's see. Trying to remember how to do stoichiometry. Well, let's take a closer look at this. This shouldn't take very long. I made out a little problem. I just generically made this up. So let's see what happens. First of all, it says we have 4 grams of potassium chlorate. How many grams of O2 is produced? Short and sweet, right? This is our given. We have this. Orange. This is our unknown. How many grams of O2? So there's our 2 things we're going to start with. We're going from grams to grams. You know the pattern, right? I hope you do. The pattern goes grams to moles to moles to grams. Now that's not just the whole pattern, right? We always start off with the with the given. So these first 2 things are the given. These will be the grams of potassium chlorate and the moles of potassium chlorate. The second part of the grams to moles to grams is the unknown. And it'll be moles of oxygen and grams of oxygen. You can only have 2 formulas per stoichiometry table. So don't try to throw in all 3 formulas because there's 3 formulas in there. You can only use 2. The given and the unknown. Grams to moles to grams. Given, unknown, unknown. Let's get started on this thing. All right. So we have 4 grams of KClO3. Right? Now we're going to follow our pattern. Moles. KClO3. Moles of O2. Grams O2. All right? That's our pattern. That map is the top shelf of the periodic or of the factor label table. Right? That's it. That's why we have it. Okay, now the second part of this is easy. We're just going to cross out our labels. Grams of KClO3. KClO3 go down here, right? It's right here. I just put it down here. I'm going to cross it out. Moles of KClO3 go down here, right? It's right here. I'm just crossing it out. So I'm just crossing out the labels. That's why it's called, or factoring out the labels. That's why we call it factor label. Moles on the bottom of O2. All right? See? Now let's put the right numbers in this thing. So that's the key to this thing, is putting the right numbers in. Okay, so if we have moles and grams, moles over grams or grams over moles, that mole is going to be 1, right? Because we want to know the mass of 1 mole. So we look on our handy-dandy periodic table. I don't even have my calculator out here yet, so I'm going to jibber-jabber and stall a little bit so you guys think that I'm, okay, just chit-chatting, but here we go. So first of all, we find potassium. Potassium weighs 39. So 39 plus chlorine, which is 35, plus oxygen, which is 16, and there's 3 of them, so 16 times 3 equals, I got 122. So KClO3 weighs 122 grams per 1 mole. Okay, now we're going to go to the very end because we have grams over moles. If you have moles over grams or grams over moles, the moles is 1, and the grams is the mass from the periodic table. So remember, we just said oxygen was 16, and there's 2 of them, so that's 32 grams of O2. Okay, now our last step. The last step is called the mole-mole ratio, or the mole-mole, right? So we have our mole-mole, and our mole-mole has moles of O2 and moles of potassium chlorate. So all we have to do, oops, not an erase, I want to change the color of the highlighter. We better do this in bright green because that will really work. Is we have to find out what number what coefficient we put into the balanced equation. That's the whole reason we balance equations, is for this step of stoichiometry right here. So if we look very closely, now it's in green, the oxygen gets a 3 moles per every 2 moles of potassium chlorate. And now she's set up for you. All right, now here's how I punch this into the calculator. I don't like to use parentheses and weird things and have to rewrite stuff. So I'm just going to go 4. I'm going to put the 1 in just for now. 4 times 1 times 3 times 32. So everything on the top, multiply. And then you have to put a divide. Divide by 122. And we're not using parentheses, so we're going to push divide again. Divide by 2. And I'm going to do this for fun. Divide by 1, right? You don't need the ones in there really. But that's how you put in your calculator. On the bottom, just put a divide in front of it, and you don't have to worry about any weird fractions or any rewriting or anything like that. You just divide. All right? And punch that in and see what you get, and that should work out just fine. You want me to do it? Okay. So 4 times 3 times 32 divided by 122 divided by 2 equals, I got 1.57. Oops. All right, and that's grams of O2. All right, and that would be your stoichiometry. Almost every stoichiometry problem follows this same pattern. So if you've got that down, you're good to go. If it starts with moles, they try to throw you a little curveball, and they want to start with moles. Let me erase my thing here. Right? So we have our pattern. Oh, come on, erase. Our pattern is grams to moles to moles to grams, remember. And those first 2 were the given. Those last 2 were the unknown. And so if they try to throw you a curveball and start with moles, you know what you do? You start with moles on your map. You just cross out the grams. Now you have moles to grams. If they want you to go from mole to mole, right, then you just cross out the other grams. So you can use that map how you want to use it. You don't have to start in the beginning. You can cut off the ends. It always has to have the mole to mole, though. That's what makes it stoichiometry. All right, I've talked too long, so I'm out of here. Take it easy.